All right, so today we're going to be doing the problem set for the exponential and logarithmic functions. And specifically, I want to look at the odd numbers. So we're going to be doing 1 and 3 today. Number 1 gives us an exponential function. F of x equals 2 to the x power. The first thing I need to do is I need to name the parent function. The parent function. We can call this an exponential function. Exponential function. And if we wanted to show the formula for this, in general, an exponential function is y equals some number a to the x power, where a cannot be equal to 0. So that is our exponential function. It is one of the parent functions, so it does become very important once you get to Algebra 2 and pre-cal. But the exponential function is y equals a to the x power. Is there any transformation that we see to the function? Well, no, there is no transformation. So I'll write no transformation. We do know that the base for this is going to be 2 because we have 2 to the x power. Let's look at the domain. What is the domain of this function? And do know that when I mean domain, I'm talking about the set of all x values. Well, if you were to graph this, you would see that the function goes all the way from the left, all the way to the right. So essentially, it goes from negative infinity to positive infinity on the x-axis. So the domain is going to be all real numbers. All real numbers. So let's take a look and see what that looks like. I'm going to go over to Desmos and I'm going to graph this. F of x is equal to 2 to the x power. And that's going to give us this red function right here. Okay? So you can see from the function that it goes all the way to the left and the right side goes all the way to the right. So every single x value is going to have a y value. Another way you can think about that is every single input is going to have an output. So the domain is going to be all real numbers. But what is the range? That's my next question. What is the range? Well, the range is going to be all the y values. And looking at the graph, the only y values that the graph is going to take up is all the positive numbers, right? The graph never dips below the x-axis at all. It never actually crosses the x-axis, but we'll get to that later. So the range can't be 0 or any of the negative numbers. So one way we can write that is the y values must be greater than 0. Okay. So for exponential functions, are there any vertical asymptotes? No. Exponential functions do not have vertical asymptotes. So I'm going to write none. But we do have horizontal asymptotes. And that's what it asked me in the next question. Do we have any horizontal asymptotes? Well, it turns out that we do. And I'll show you what the horizontal asymptote is when we go back to the graph. So looking at the graph here, the horizontal asymptote is going to be x equals, well, actually y equals 0. Because this is the x-axis, right? So we can zoom into this and we can see that the graph is never going to cross the x-axis. In fact, the x-axis is a horizontal asymptote. And the way we write that is y equals 0. Y equals 0. And y equals 0 is also known as the x-axis. Okay. So the last two questions ask for x-intercepts X-intercepts. And the last question asks about the Y-intercepts. Are there any Y-intercepts? Well, starting off with the first question, if there are any X-intercepts, it would be where the graph crosses the X-axis, right? So I'm going to look at the graph, and since it never crosses the X-axis, there's not going to be any X-intercepts. So for that, I'm going to write none. What about the Y-intercepts? Well, to find the Y-intercepts, what you could do is you could let X be 0 and see what happens. So if we're dealing with a function f of x, and we know that the function has an independent variable of x, what we could do is we could test out what happens when x is 0. So I'm going to replace x with a 0 and see what happens. I get f of 0 is equal to 2 to the 0 power, which is going to be 1. So 1 is actually going to be the y-intercept. Y equals 1. But that would be the equation of a line. The way I would write it is as an ordered pair 0, 1. So that's going to be the y-intercept. And we know that it's y equals 1 because when we look at the graph, it's going to cross the y-axis at the point 0, 1. So that is why that is the y-intercept. Okay. So that's exponential functions. You're always going to have a base raised to an exponent, and that exponent is going to be the variable x, or whatever variable you have. All right, let's look at number 3. The second and last one we'll do today. F of x is equal to log base 3 of x. Okay, so to start off with, this is a logarithmic function. It's very plain, so how could you not tell? It's a logarithmic function. Typically, when you write a log function, you're going to have a logarithm with some base. We just call it b if it's unknown. And we're going to have the variable inside the parentheses right next to it. So the way we would read this is log base b of x, log of x. And right now, the base is going to be a 3. So we can say that the base is going to be a 3. Okay? There's not any transformations going on with this function, so I'm going to write no transformations. There's no movements to the right or the left, up or down. There's no reflections or dilations or anything like that. So there's not going to be any transformations for this function. Okay, so now let's talk about the domain. And to see what the domain really looks like, what we're going to do is we're going to graph this log base 3 of x. So I'm going to go on over to Desmos, and I'm going to type in f of x is equal to log. Where's the log button? It's actually going to be under functions. So you click functions and log base a. You get that. And then our base was 3. So I'm going to put a 3 underneath the g. And then inside the parentheses, I'm going to have an x. So this is our function. It's in blue. And we can see that the function has a vertical asymptote. It's on the y-axis. That would be x equals 0. So when we do our domain, we're looking at all the x values, right? Well, the x values are only going to be positive numbers this time because the graph never crosses the y-axis into the negative x values. So our domain is going to be x has to be greater than 0. So we're going to write x is greater than 0. What about the range? What y values does the function take up? Let's take a look at it. The function is going to go all the way down to -infinity on the y-axis. We can just kind of drag the function and see that it's never going to stop. On the other hand, does it go all the way up to +infinity on the y-axis? In fact, it does, because if you keep on going to the right, and I'll kind of pan on over to the right here, the function is going to keep on going up. So the log function is going to have a range of all real numbers. All real numbers. So you can write that. You can write the boldface R, that stands for all real numbers, or you can write it as the interval -infinity to +infinity. So that's all the y values. We call that the range. Okay. The next thing is vertical asymptotes. Does this function have any? Well, let's look at the graph. So looking at the graph, it appears that the graph does have a vertical asymptote, and it's going to be the y-axis. And the way we write that is x equals 0. So we're going to have x equals 0. Now, how about horizontal asymptotes? Does it have any of those? Well, logarithms never do. They never have horizontal asymptotes. They only have vertical ones. So we can write none right here. Okay. And the last two things. We're going to find the x-intercepts and the y-intercepts. The y-intercepts. So these are the places where the graph is going to cross the x-axis and the y-axis, respectively. So if I look at the graph, where is it crossing the x-axis? It's crossing the x-axis right here at 1, 0. So the x-intercept is going to be 1, or we can write out the ordered pair, 1, 0. And that's what I usually do. Okay, but where does the function cross the y-axis? That's going to give us our y-intercepts. Well, when we look at the graph, it never does, right? It never crosses the y-axis. It'll get very, very close to it, for sure, but it's never going to actually cross the y-axis. So that's why there's not going to be any y-intercepts. So I'm going to write none for that. Okay. That is the problem set, and I hope that helps.